Welcome to SmartMind AIverse, Origins of AI. In this module, we'll trace how artificial intelligence began and took shape, from bold ideas to first experiments, and onward to a technology reshaping how we live and work. Let's start at the beginning. In the 1940s and 1950s, Alan Turing asked whether machines could think, setting a new agenda for computing. He proposed a conversation test for intelligence. Focus on answers, not the machine behind them. If a machine's replies felt human, it would pass. Turing's ideas fueled wartime code-breaking and post-war debates about minds, symbols, and reasoning. Most of all, he reframed intelligence as behavior we can observe and measure. In 1956, researchers met at Dartmouth and named the field artificial intelligence. Their aim was ambitious: build machines that learn, reason, and use language. Pioneers like John McCarthy, Marvin Minsky, and Herbert Simon set the early direction of AI. McCarthy created Lisp, Minsky advanced perception, and Simon explored problem-solving and decision-making. Soon, labs turned ideas into working programs. Funding and curiosity drove rapid experiments across universities. Logic theorists proved mathematical theorems from first principles, an early glimpse of machine reasoning. Eliza mimicked conversation with clever pattern rules, revealing both charm and limits. These demos showcased promise while exposing how hard true understanding is. Still, they inspired visions of assistants, tutors, and helpful smart machines. That momentum set the stage for the booms and winters that followed. Ambition soared, but early hardware hit a wall. When progress stalled, funding cooled, and optimism faded. The first AI winter. Then, a cautious thaw began. In the 1980s, expert systems captured human know-how as rules to mimic decisions. Great for narrow tasks, brittle outside their rules. Enterprises deployed prototypes in medicine, finance, and engineering to codify expert workflows. But building and maintaining thousands of rules was slow and costly. Real-world uses looked promising, when carefully scoped. Diagnosis aids, fraud detection, and design planning, the era's showcase wins. Costs rose, data shifted, and systems failed to adapt to change. Momentum dipped, ushering in a second AI winter. Budgets tightened, and enthusiasm cooled again as returns lagged. Yet research pressed on, refining statistics, optimization, and neural nets. Quiet progress, better algorithms, more data. Meanwhile, storage grew cheaper, and the web exploded with signals. The ingredients were gathering: compute, data, and techniques, waiting for a spark. By the 2000s, compute surged. Learning from data outpaced hand-coded rules. Machine learning took the lead. With GPUs and open-source tools, models scaled beyond earlier limits. Industry reinvested heavily. Google, IBM, Microsoft, and others. Cloud made training accessible. Deep learning reignited AI's momentum. Next, we dive into how it works. In the 2010s, deep learning sparked a revolution. Computers suddenly saw models beat benchmarks, spotting objects, tumors, and street signs with superhuman accuracy. They listened and translated. Nets turned messy sentences into fluent language across dozens of tongues. And they mastered strategy at world-class level. AlphaGo stunned Go champions. Chess engines explored creative, non-human lines of play. Those wins unlocked today's wave of AI. Today, AI hums in the background, helping your assistant understand and anticipate you, supporting doctors with pattern-spotting diagnostics and second opinions, enabling artists and everyday creators to generate images, music, and text, and steering autonomous systems, from warehouses and robots to self-driving cars. The journey from a simple question, "Can machines think?" posed last century to an AI-shaped world is only just beginning, for all of us. Every great technology has a story, and AI's is one of resilience and innovation. Subscribe to SmartMind AIverse, and in the next module, we'll explore how AI actually works.